Okay. We've got one-step inequalities. This time we're going to multiply and divide. For the most part, they're very similar. So if I have 3x equals 15, 3x is greater than 15. So this right here, they're going to actually solve the same way. I'm going to divide off the 3's. No big deal. And an x, because those canceled out. X drops down, and 15 divided by 3 is 5. And in this case, it'll just drop down to be greater than 5. No problem. That is because this guy right here, those were positive. And when there's positive, you just roll through the problem as if it were an equation, and the sign just drops down. All right, so let's look at something else. Okay? And I'll come up with a different problem for that. Let's suppose I have negative 2x equals 8. That's my example problem for an equation. So of course I want you to see it over here, negative 2x is less than 8. Now it's an inequality. So in order to solve this guy, I need to create that identity number 1 there. So I'm going to be dividing by negative 2 because we know that the x, when it drops, doesn't want to wear that negative sign. And here we're going to get x equals negative 4. All right. Now the calculation on the right, where I have the inequality, is going to go exactly the same. Negative 2 on both sides of my little wall here. There's my wall. And I'm going to get x dropping down and negative 4 dropping down. Now, this guy right here, the one doing the work, was negative. So that negative is going to flip the sign. Remember when it jumped into the distributive property, it flipped signs? Well, he's in a bad mood again. And if this guy is a negative number, when you multiply or divide, you flip this sign. And your number line in this case is going to be 4, negative 4. And x is greater than. Okay, that is for multiplying and dividing. Positive, you just roll right through it. Negative, he flips the signs. Let's look at a division problem so you can see what that looks like again. If I have a over 7 equals 3. Again, this is the equation version. A over 7 equals 3. In order to get rid of it, I need to multiply by that 7 on both sides. When I do that, it allows those 7's to cancel out, and that a will drop down. 21. Same thing is going to happen over here. Let's put my little wall up. Okay, and we're going to multiply by 7 on both sides. My 7's canceled out. My a dropped down. I didn't put a sign there. This is going to be 21. And let's just say this was less than or equal to. Now that 7 that was doing all the work was positive, so my less than or equal to will just drop down. And again, on my number line, 21, 0, negative 21. There's my 21, less than or equal to, we'll color it in. Okay, and one last example with a division. We'll make this one the hardest one yet. Negative 2/3 x equals 12. That's my example as an equation. Negative 2/3 x less than or equal to 12. So let's put our little wall down, and we know that whatever I do to one side, I have to do to the other. So I need to get that 2/3 off of my x. It needs to be unhooked. So remember, a fraction is a division problem, so the way I'm going to do that is I'm going to multiply on both sides. I may as well set it up over here as well. Now what we're going to do is we're going to multiply by the reciprocal. This guy flipped over, 3/2. And I'll do it over here. So you can see the calculation is exactly the same. Now remember, my x doesn't wear the negative sign, so I have to make sure I bring it with me. Okay, now when this happens, over on this side, all of this, -3 times -2 gives me +6/6 gives me 1x by itself. And the same thing happens over here. On the right side, I have to put a 1 underneath here. And I'm going to get 12 times -3 is -36/2. Yeah, x equals that, -36/2, but we need to simplify it to -18. Well, we did all the calculation there, so -18 will go here. But remember, right there, that was a negative sign. So it's going to take my sign and flip it. See how it's flipped when it went down? So on this number line, it would look like this. 18, -18. X is greater than or equal to -18, so a -18 is my dot. It is greater than, colored in, or equal to. Coloring better. There you go.